we notice that this blue triangle and the yellow one share the angle, which means they're the same by the reflexive property, as well as the side overlap. So we are going to talk about how to prove triangles that overlap each other, because they're going to share something. Okay. So this first one says, determine whether there are any congruent triangles in rectangle ABCD. Give a congruent statement for any congruent triangles. Okay, now there's lots of different ones. We're not going to name all of them here, but I want you to kind of think about what two triangles might be congruent in this rectangle. And remember, rectangles have opposite sides that are equal. They have 4 right angles, and their opposite sides are also parallel. Okay, we're not going to talk a lot about rectangles, but we do know that that's true. So what do you think? Can you see any triangles that would be congruent there? A, B, C, and what? And A, B, C, okay. Okay, so those two triangles right there, they are congruent to each other. They have, let's see, opposite sides are equal, right? And then they share that middle one, so you can prove that congruent by SSS, right? Okay. Now those don't really overlap except at AC, correct? Okay, let's see if we can find ones that overlap a little bit more. Let's work with ABC again. Is there something else that would be congruent? C, B, D, okay? C, B, D, C, right? So, this side's congruent, right? They both have a right angle. Okay, what else? We have this side, this angle. No, I'm wanting you to, I've only said 2 parts. BC, they share BC, right? Okay, so I can say that triangle ABC is congruent to triangle BCB by what? Well, BC is congruent to itself. Yeah, so
overlapping triangles.
So that's not a reason. You have to use SAS, ASA, SSS, SAS. Not SAS. Okay. You have to still use one of those reasons. It's just the triangles that we're looking at today overlap. Okay? Alright. So, and there's more. But I want you to see that that these would actually be congruent to each other. Okay. There's another one. Is FHJ congruent to triangle GHG? KHG. Alright, so I'm going to highlight them. FHJ. There's FHJ. And then sometimes it helps if you separate them, slide them apart. Sometimes that makes it just a little bit easier. So this right here is F, H, K. And then here is KHG, KHG. Okay. This is H. Okay. All right. So we can see from the picture that this F and this K are equal. Okay. Now, there's an L here, and it says that this and that have those marks. And then there is an L here, and so they've got a single and a double. Okay, so I've separated them. They're drawn at the same size. But anyway, I've separated them. I can see that F and K are congruent. What else could I determine? GHK. GHK and what? FHJ, right, GHK. So this angle is congruent to itself. It's shared by both of them, right? Okay. So this angle is congruent to itself because it's shared by both of them. Okay. So that takes care of 2 angles. Now I need a side. Now look at these right here. See how FJ and KG, they're both made up of a single dash segment and a double dash segment. Yes? Could I add those 2 together and it be equal to each other? Yes, okay? Whatever, like say 2 plus 3, 2 plus 3, that'd both be 5, alright? Okay? So you can add those two together. So that tells me that this side and this side are going to be congruent to each other. So why would these triangles be congruent to each other? AAS. So YAAS. Okay? Let's look at this one. EGD and EFH. EGD. So EGD, which I'm going to draw it out here. And then EFH. Okay, what do you think? What's the question mark? Okay, so we have one pair of sides that are equal, yes? Okay. You notice anything else?
Sure.
Well, but it's not the same E. Because you've got, see how the red is right here and the blue is right there? They're not exactly the same. They overlap each other, but they're not exactly the same.
DG and FH are the same because FG is congruent to its side.
Okay, so you said, what'd you say? DG and FH, is that what you said? Okay, you are correct. These two segments right here, this segment and this segment right here, are equal to each other because they overlap right here, don't they? Okay? And these two pieces, DF and HG, are equal. So if I add something that's equal to itself together, then the whole thing is equal, right? So I can add, just like in the other problem, I can add these two pieces together so the whole thing is equal, okay?
What did you do?
I did do 3, it just overlapped each other. Did it again. There. Okay, so we have this side and this side. We have these two sides. Now, I need one more thing. No, I don't know anything about these two sides. Now, look at the big picture. If I look at this big picture right here, what kind of triangle is that?
Oh, so by a triangle.
It's an isosceles triangle, right? And an isosceles triangle, if the two legs are equal, what do we know? The base angles are equal. So this D and this H are equal to each other, yes? Okay? Alright, so now can we prove those two? Yes, by SAS. Okay, by SAS. Okay, and here is a couple of problems that it just kind of shows you some different ways to prove the triangle is congruent by overlapping triangles. We talked about one like this a while ago, where you've got this triangle here and this triangle here. They share that part in the middle, and the other pieces are congruent to each other. They're side, side, side. Okay. Here's another one. I think we did one similar to this one, maybe. There's this triangle and this one. Okay. And they share this angle. Okay. They have a side, and then they share this one right here. Okay. So that would be angle side. Alright? Here's a hypotenuse leg one, where you've got this triangle, and you've got this one. Okay? So it's a right triangle. They have this side equal to each other. And then just like in those other two problems on the other page, you have a single and a triple dash, and another single and a triple dash. So if you add those together, the whole thing would be equal, right? So that is a hypotenuse leg. Okay, so there's lots of different ways this can be done. Just trying to show you a couple different ways to do it. Okay, so let's do these two proofs. Okay, it says that AB is perpendicular to BC and DC is perpendicular to BC. What does that give us? It means we have here, and we have a right angle here. And we also know that angle A and angle D are equal to each other. And they're wanting us to prove that ABC is congruent to DCB. All right. They share BC. Okay, good. They share BC. We have a right angle, which means either we can say it's a right triangle, or we can say that those right angles are congruent, right? And then we have another pair of angles. Which way should we go with this? Right angles are what? Congruent to each other. Okay. And so if we get it, then these two triangles be congruent to each other by what? AAS, right? Okay. All right. So we have our perpendicular lines, which means that we've got two right angles. And we probably need to be specific. So we need to say angle ABC and angle DCB are right angles. Okay, and that's by what reason? Definition of perpendicular. Okay, because they're right angles, what else is true about it? They're congruent to each other. Okay, so angle ABC is congruent to angle DCB, and that's by the theorem all right angles are congruent. Okay. Alright, and then you said they shared BC, correct? Now, if I said BC for the red triangle, so what I say for the blue one? I would have to switch it to CB. Okay, good. Alright. And that is by the reflexive property. So are we good? Okay, so now we can say that triangle ABC is congruent to triangle DCB by AAS. Questions on what I did there? Okay, got one more. Now, I'm just going to forewarn you, this is a little bit lengthy. There's one that's kind of like this on your homework, and you can do it this way, but there's also an alternate way that can be done. So one way's short, one way's long. You just have to figure out which one's going to work for you. Okay. All right. So we have triangle AED is isosceles with vertex angle EE, and then we're also told that AB is congruent to DC. Okay, so we know those two pieces are congruent, and we know that AED is isosceles. What do we know if AED is isosceles? Okay, that AE and ED are congruent. We would have to state that. Okay, because all it tells us is isosceles. We have to state which legs are congruent. Okay, and it tells us where the vertex angle is. And that would be on the definition of isosceles. So now we have these two sides right here. Okay, and then we also have AE and DC. What else can we get? No. Because ultimately, we're trying to prove, it's not like that other problem. We're trying to prove this triangle here is congruent. Okay. So this triangle here, you said A is congruent to B. Yes. And why is that? It's an isosceles triangle, and so those base angles are congruent. That's called the isosceles triangle here. Okay. So we know that these two angles here are congruent. Okay. So we've got the side, we've got the angle. What else? Okay. BC and CB are shared, right? Okay. But what we need is we need to show this side here is equal to that side. Okay? Alright, can we do that? We know already that these two pieces are equal and this is shared, yes? So could we add the shared part to both of the other pieces that are equal? And it would make it the same, right? Okay, there's a little time consuming to do that, so I'll show you how to do that. Alright, so let's congruent to DE, right? And what was my reason for that? Definition of isosceles. Triangle. Okay? Then we said because those two sides are equal, what else is equal? The angles, right? So angle A is congruent to angle D, and that is the isosceles triangle theorem. Okay? Alright. Now we've got to add that BC to both of those equal parts. These are the two congruent parts. Now, before I can add to it, I need to change that into equals. Is that from chapter 2? Or chapter 1? I don't remember what chapter it was. Okay? So instead of AB congruent to DC, I need AB equals DC. And that is definition of what? Definition of congruent segment. Just congruence is fine. Okay? So then I'm going to take this, the fact that AB equals DC, and I am going to add that shared part to both sides. I'm going to add AC to one side, and I'm going to add BC to the other. What's that called? When you add the same thing to both sides? Substitution. We're going to use substitution. You added, right? Just like when you add 3 to both sides of an equation, Aiden? Isn't that addition? Okay. All right. So this is addition. Okay. Now, instead of it being AB plus BC, I want it to be AC. And instead of it being BC plus CD, I want it to be BD. So I have to establish what makes those bigger segments up. So I'm going to say, okay, what makes up AC and what makes up BD? What makes up AC? AB plus BC. And what makes up BD?
BC plus CD.
BC plus CD. Good. And what's that called when you say this whole part is equal to the sum of its parts? Segment addition postulate. Good. We're having to clean some cobwebs out, huh? Segment addition postulate. That's a little while ago. Okay, so we're almost there. Now, you said we were going to use substitution, right? Okay, so here we've got AB plus BC, and here it says AB plus BC equals AC. So can I replace this with AC? Yes. So that's what I'm going to do. I'm going to replace this with AC, and I'm going to replace this with what it's equal to, which is BD, right? And that's called what? Substitution. Okay, so I've got that whole big piece, but I need to change it to congruence. So AC congruent to BD, which is definition of congruent segments. Okay, so I'm almost done. I have this side stated, I have this angle stated, and now I have the yellow and the pink equal to each other, right? So what does that establish with a triangle? Well, well, yeah, they have that side equal to each other. So, you know, this yellow is equal to the pink. That establishes what you say? SAS, side angle side, right? So we have this side, this angle, and now we've got the yellow and the pink, right? Okay, so we can prove triangle AEC congruent to triangle DEB by SAS. That's fun, wasn't it? So really, this part right here all goes with adding the parts together. I mean, the idea was easy and just establishing how you do it. Now, like I said, on your homework, there was one problem I had intended for you to do that with. However, there's an alternate way. If you can figure it out when you do it, you can do it this way, you can do it the alternate way. So I'm just going to let you try to figure that out, okay? Now, let me ask you one more question. When does CPCTC come in? Okay. When you already know what? You already know the triangles are congruent, right? And you're trying to show one of the other pieces, right? One of the other parts. So what's the CPCTC stand for? Corresponding parts, congruent triangles are congruent. All right.